Understanding access control lists, focusing on extended ACLs. This is the final in the trilogy of access control list nugget, and I think that we've saved the best till last, just because extended ACLs are a lot of fun. So this is going to take the same format as we did with standard ACLs, which is diving headlong into 3 practical scenarios that we have to solve, and then working through the syntax as we solve them. Well, just as we did in the standard ACL nugget, let's do a quick lay of the land on our network topology. 3 routers connected via WAN links. You can see the WAN links are /30, so each one has 2 IP addresses. There's .1, .2, .5, .6 going on there. Each one of these routers has its own LAN that it's protecting. This one a Class C 192.168.1.0. .1 is the default gateway, fast Ethernet 1/0, so all the individual ports are labeled on here. Good so far, right? Down at the bottom, we've got a /25, up top /25. I did that just because it's going to throw us into some funky wildcard mask worlds, which Cisco just likes asking weird wildcard mask questions on certification exam. So even though I would say this is a lot more common in the old days, I don't see as many at least small subnets like that. Usually people are going to do like a /23 or /22 to get kind of a bigger subnet. But nonetheless, this is what we did. /25 gives you an increment of 128. So this network is really defined as 2.0 through 127, 127 being the broadcast, 0 being the network, so 1 through 126 being usable. Up here, 128 through what? 255, right? 255 being broadcast, 128 being network, so 129 through 254 being the usable. You can see the default gateway is the .129. Are we good? Good. PCs, actually, let me just bring up the prompts here. There we go. I'm still using Secure CRT. This is now officially my second nugget where I have used Secure CRT, and I'm very excited about it because, well, I'm not going to explain that all over again. So go watch the standard ACL nugget if you want to hear that. So PC1, PC2, and PC3 really are just routers. And what I've done is I've stripped them of their routing ability. You can do show IP route. It says the default gateway is just this because I went into global config mode and did the no IP routing. You can see this command right here, which turns off routing and then just says, what is my default gateway, which I set using the IP default gateway command saying this is where you go. So PC1, PC2, PC3 really are just a Cisco router, but essentially acting like a PC. There we go. We've got it, right? Okay, so scenario number 1. Use an extended access control list to block 192.168.1.0 /24, that's this subnet right here, from reaching 192.168.2.128, which is this subnet over here. Now, hang on. I know some of you are coming out of the standard ACL nugget going, wait a sec. Couldn't we do that with a standard access list? As a matter of fact, isn't that similar to what we did with the standard access list? And it kind of is, and yes, you actually can accomplish this with a standard access list, which you can do just based on source address. You can say, I want to do a standard ACL matching, or I'll say denying 192.168.1.0 /24, and you can put it where? Right here. Right? Router 2, fast Ethernet 0/1, apply that bad boy outbound. So these guys will cross the network, come down here, and as they come out to reach the subnet, oh wait, whoa, sorry, wrong subnet. So bank left, coming up here. So router 3, some of you are like, wait a sec, I thought I understood it. No, you do. So it would be on this interface outbound, right? I just was looking at the wrong subnet. So as it comes out here, so this guy kind of takes the road trip getting all the way across here to go bam, hit the wall of the access list and getting dropped right there as it tries to go out gig 0101 on the iOS XR, right? So yes, you can accomplish that using a standard access list, but not efficiently, right? So here's what we're going to do. Extended access lists have a key rule that Cisco always recommends. With extended ACLs, always apply the ACL as close to the source, underline, as possible. Why? Because extended ACLs can block based on source and destination and protocol, important, blah, 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 blah. So I can say, you know what? This subnet is denied from reaching that subnet, and you don't have to take the road trip to find that out. Because with the standard, I can only block based on source, so I have to apply it all the way here. This one, I can say, you know what? I'm going to apply that right there. literally the default gateway of that subnet. As it comes in, I'm going to say deny that guy, that's our source, from reaching that destination, and bam, it gets blocked before it ever leaves the gate. How much more efficient is it than driving all the way across the network just to find out you're dropped, right? So that's one of the benefits. And we can put some permit statements in there as well to make sure that it can still reach everything else, right? So I'm ready to go. Let's jump on router 1. Now, I don't want to, as I get into the configuration here, I don't want to bypass the importance of that little internal monologue I just had on, where should this be? Well, let's apply it at router 1, because that's really the crux of your design. Meaning, you don't want to just start configuring access lists without knowing where it's going to go to start off with. So just identifying the fact that we're going to be on router 1 was a key part of this ACL scenario. So, router 1. Go into global configuration mode. We can go the old school route of using the access list command and specifying that we're going to use number 100 through 199, which designates that this is going to be an extended access list. But I told you a little while back, I've stopped using numbered access lists because it's just so much easier to do a show run and see the name of it and immediately know what that access list is there for, right? So I'm going to do an IP access list now. Notice extended. So I squeeze the IP at the beginning, right? That's how we go down the road of doing a named access list. Extended, and we're going to say, instead of using a number, which I can do, I'm going to use the name. We'll just do block, let's just call it block 1. I know these are random scenarios, but usually I would have something like accounting restrictions or some logical name like that, and hit the enter key, right? Now on iOS XR, we can just keep on typing right there, not on the iOS. So I go into a named access list configuration mode. This is where I've got my options of sequence numbers and all that. Now, this is where we get the syntax down, right? Right here, right now, in the live scenario. So I'm going to do a permit and hit the question mark. Now, if we were doing a standard access list, it would just say, what's your source IP address? End of the road, right? No other option to type in there. Now, the first thing that it has is, what protocol are you using? Okay, hang on one second. Big thing with extended ACLs. Extended ACLs have 3 big points. One, well, I guess we could say permit or deny. So how about 4? So permit or deny will be the first big point that you do. And it's always in this order, right? Then you have the protocol. Then you have the source info. And then you have the destination info, right? 4 big points. Number 1, number 2, 3, and 4. Remember that. Tattoo that to your forehead. I mean, just keep that in mind, because when you get into the syntax, I mean, a lot of people on extended ACLs are like, oh, it's so confusing syntax. It's totally not if you just remember the 4 points. Permit or deny, what protocol, source, and destination, right? So first thing we're going to say is, what protocol? Well, explain this to me, Jeremy. What do you mean, what protocol? I mean that there is a whole bunch of protocols in the TCP IP protocol suite. There's TCP, there's UDP, which is about where most people stop when they first get into networking. They're like, there's more? Yeah. So ICMP, things like echo reply, which is our ping, ICMP unreachable messages, ESP, which is used for VPN connections, EIGRP, where have we seen that before? These are actually, I mean, these are routing protocols, but they are actually at layer 4 in the OSI model. They don't use TCP or UDP. They're their own little protocol, right? So access lists can deny all of them or permit all of them or whatever you want to do. Now, each of them have a protocol number. If you are a stud, you will remember all 255 protocols, or actually 256. I'm not. I just remember the names, and I'm so grateful for Cisco that they type a named list right here. I think TCP is 6. I think. Anyhow, IP is the protocol of everythingness. A lot of people, when they see this, they're like, okay, keep them from reaching this. A lot of people go down the road of TCP because they think, oh, well, just about every application is TCP based. Well, yeah, but there's stuff that's not, right? IP is the any internet protocol, everything, right? So I'm going to say permit IP. Now what? Well, we've moved from permit or deny, got that. Protocol, well, hang on, going green. Permit or deny, got that. Protocol, got that. Source is now where we're at. What source address? Well, we are going to say it's the entire 192.168.1.0 subnet. Now, same discussion of wildcard mask. I'm going to leave that in the standard ACL. We talked about wildcard mask. Can I emphasize how hugely important it is to know how to figure a wildcard mask? If you need some assistance with that, jump back into the standard ACL micro. I keep saying micro nugget because that's CBT Nugget's kind of new cool thing. Yeah, we talk talk about all about in there. Okay, so wildcard mask, I'm going to do 0.0.0.255, right? And essentially these are identification bits where I can say, look at this, look at this, look at this. Oh, missed it right there. Ooh, there. And I don't care. I'm just not good there. I don't care what's in that last octet. So anything starting with 192.168.1. Now, hang on a second. Where are we going to apply this? Right here, right? Inbound. So as something is coming into our router on Fast Ethernet 1/0, it will be filtered through this access list. So question for you, could I get away by saying, oh, wait a sec, I'm going totally the wrong way. Deny, right? Oh my gosh, I'm so sorry. I know some people are watching, they're like, oh, you know, I'm like, I feel like 5 people probably rewound like 3 times and they're like, he's totally wrong. He's totally wrong. And I am. So deny IP. Okay, now I have gotten away just by typing in any right there? Think about that for a second. Could I? Yeah. Based on the network diagram, I could have said deny IP anything, because when I apply this inbound right here, the only thing that's shown in this diagram that's coming in is 192.168.1.0, right? That's the only thing that exists over there. So yes, 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 that would work. And no, if you're on the Cisco exam, do you want to do that? The reason why, and I could totally see Cisco's justification in marking you wrong for doing this, is they're saying, well, yeah, 192.168.1.0 is there right now, but what about tomorrow? What about when we add another voice VLAN over there? And it's 172.16.1. Well, now we've got to change our ACL to be more accurate, because any will accidentally catch the voice VLAN as well, which we may not want to do. So if can you get away with it in the real world? Absolutely, yes. On the exam, they'll probably deduct some points. So deny IP. So this is our source, and now it's saying, okay, what's your destination? Now, one thing that you will see change as we go further in these scenarios. Right now I'm saying IP, which is everything. But as we move forward and I hit the question mark with some other protocols like TCP or UDP or whatever the case is, you'll actually see the option here for port. But the Cisco's router is smart. It's going, okay, there are no ports if you're talking everything. So we don't see that option. So now we're into the final one. We did the source. Now we're into the destination. Well, deny them from where? If we type in anything, then we might as well unplug their cable. They're denied from everything. No, no, no. We're going to 192.168.2.128, which is the network ID of this, with a wildcard mask of whatever the opposite of a /25 is. You might remember in the standard ACL nugget, I talked about the quick and easy way to figure out a wildcard mask is just to take the subnet mask, which a /25 is 255.255.255.128, and subtract it from all 255s. That kind of gives you the inverse of it, which is another name for the wildcard mask is inverse mask, 0.00127. That's what that comes out to. So we will say, and it feels weird every time you type one of those in, 0.00127. 127. There we go. Good. Right? Now that's cool, and we can apply that, and we will have devastation, because at the bottom of every access list is a deny everything, right? So we're going to have to add, I'll do a permit IP any on that as well. Now, the good news is we're not applying this. Oh, such a big thing. You know, in the standard ACLs, I talked about the reload in command, which is really good to do just in case you kill your connection, you know, mistype in an access list or something like that, right? One of the things I will mention is when you are making changes to an access list, it is also good to remove the access list from the interface before you make those changes and then reapply it, if at all possible. Okay. Now, I'm not saying that I always do this. Matter of fact, I rarely do it, but it's a good practice, because as soon as you type these commands in, they take effect. One thing that I've done, let me just give you the last major outage Jeremy caused, happened like this. I was actually working on a router where you apply these access lists, how? Through the IP access group command, right? And what I did was I went in and I said, oh, I got to make some changes to this access list. And I decided, you know what? I'm just going to blow the whole thing away. So I did a no access list. In this case, we would say block 1. And it deletes the whole access list. But the IP access group command stays there. Now, in some iOS versions, it does not, but on most, it does. So what that means is I blow away the ACL. It's empty. Now, an empty ACL actually doesn't work. It's invisible to the router. So it's even though the command is there to apply it, it isn't enacted. But as soon as you type the first line into that ACL, bam, that access group command goes into effect, and bam, there goes my connection where I was, over here somewhere and totally lost connectivity to that device. So, ouch, it does hurt. And I would really suggest if you are going to make a change to that, just get in the habit of removing the IP access group command first and then making your adjustments to the ACL. Okay, so dropping back here, let's do a show IP access list. All right, there's our block 1, sequence 10. Deny, we see our source, our destination, and then sequence 20, permit IP any. Now, it's no fun if we haven't proved that it worked first. So let's go over here to PC1, who's sitting behind there. Show IP interface brief. It's kind of like our IP config for Cisco. It's 192.168.1.50, just like it says. Show IP route. We've got, it's a dumb device just going to 192.168.1.1, which is the default gateway. Let's ping 192.168.2.150. We should have success. We see 100% success going over here to 150 at the upper a couple times. Good. Now let's hop over to router 1. I'm going to go into global config mode. Where are we going? Interface fast Ethernet 1/0, which is that interface we've been identifying in the upper left there. And I'll do an IP access group block 1, which is the access list name, and then what direction. Again, if you missed the standard ACL nuggets, I said be the router. This is your heart in the middle. These are your interfaces, right? This is fast Ethernet 1/0. This is serial 2/0, which if you don't do this, I literally will hold my hands out when I'm at a network environment to this day, because sometimes it just helps me visualize the directions things are going, especially when you're throwing source and destination into the mix. It can get confusing. So I'll say this is going to be inbound, right? Which now denies that subnet from getting there. So let's go back to PC1 and deny. You can see the ICMP unreachable messages coming back. That's the little U's there. Can come back and do a show access list at this point, and we see 5 matches, 5 pings that have been denied from making it through that access list. Awesome. Now, scenario 2. Let's drop it down. So, scenario 2, block 192.168.1.50, that's this guy, from reaching 192.168.2.50, that's this guy, using HTTP or HTTPS. Man, this guy must be like they're like, don't let that guy, just get rid of him, man. Okay, so we've got router 1. Well, this is cool. I'm thinking this is a good one because we're going to modify our existing access list, right? Because scenario 1 said block him from there. We verified that. He's done. He can't get there. Just for the sake of it, let's make sure he can't ping that default gateway on the other side. Denied. Good. And then I'm going to, oh, by the way, if you ever want to break out of a ping, Control-Shift-6 and just keep slamming that 6 key until you do that, and that's your break symbol. I'm just going to ping 10.1.1.1, which is the WAN link over there. That's this interface, and good. So we're still getting there. Our ACL is proven. We're going to add on to that ACL. So I'm going to go into global config mode. And again, identifying this as the closest to the source place as we can to deny that person. Could we apply it outbound right there? Yes. Could we apply it inbound or outbound right there? Yes and yes. And the further that you go, Cisco would consider you less efficient, right? Because you have to travel further and be processed by more devices to find out that you're denied, which is why they say go as close to the source as possible. So we're back on that router 1, and we're going to go into global config mode. Let's do IP access list extended, and we'll do block 1. Right, we're right back into that configuration mode. Now, if I just keep typing, it's not good because we've got this 20 here, which is permit IP any, and essentially theoretically, what I type would go after that. Now, the Cisco iOS is actually smart, and it will oftentimes adjust the ACL because it's like, oh, I know what you meant to do, and I'll fix it for you. On a certification exam, it doesn't fix it. So what I'm going to do is I'm going to do a no 20. Let's get that command out of there so I can kind of squeeze some stuff in there. Or I mean, right now this poor subnet just got totally destroyed, right? Because now they can't access anything. They used to be able to ping, oops, even 10.1.1.1 is denied because the only thing in that access list is a deny everything because I removed the permit statement. So you know what? Let's do this. Let's do put 20 back in there just to show you how this all works. This is pretty cool. So 20 is in there. He's back alive and well, right? Good. So now I'm going to go in and do an 11. I'm going to squeeze a statement in between. And I'm going to say deny. So we're now focused on just this guy, right? It's no longer the subnet, just that guy. So I'm going to say deny TCP, right? Again, those 4 parts that I erased. Protocol, it's TCP because HTTP and HTTPS are TCP-based protocols. So deny TCP from the host, right? This is our source. Who is it? Oh, it's 192.168.1.50, right? That guy over right there, right? Now check it out. I'm going to hit the question mark. More options. Previously, remember I was showing you before, it just gave us the destination. I said, soon it will allow you to do the port number. Now, this is where a lot of folks, even myself, when I first started learning this, gets tripped up right here because you go, ooh, port numbers. And you start thinking, okay, I'm gonna deny HTTP and HTTPS because they're specific ports, right? HTTP, by the way, it is key to know some ports. Let me give you the key ones to know off the top of your head. HTTP is TCP port 80. HTTPS is TCP port 443. A lot of people call that SSL. SSH is port 22. All these are TCP, right? Telnet, squeeze it in. Telnet is 23. Squeezing it, actually, right up here. FTP is port 21 for the control connection. What else? Oh, POP3, right? Client-based email is port 110. Squeeze it in right there. SMTP, Simple Mail Transfer Protocol. You run into this one all the time. Port 25, that's your email servers that are sending email back and forth to each other. That's it, right? Those I would say are the big ones to know off the top of your head. The only UDP ports that I would remember is port 53, which is DNS, and port 69, which is TFTP, right? Everything else, use a reference book. But those are the ones that you want to know. And a lot of times you jump right in here going, okay, well, I want to deny port 80 and 443 because it's asking for a port number, right? So you go equal to, and then it even gives you a nice friendly list, right? It's like, oh, here's a lot of the common ports that are out there. I'm going to stop that output. When I'm going through the ACL, you've got your permit or deny, right? Item number 1. You've got your protocol, item number 2. You have your source, item number 3, and you have your destination, item number 4. Now, when it comes to port numbers and TCP and UDP, you always have a source port number and you have a destination port number, right? If this guy is accessing, let's just say there's a web server right here, right? If he is accessing this web server, Windows or Linux or whatever operating system he's running, Macintosh, OS X, which is really FreeBSD, is going to generate a source port number dynamically. Matter of fact, let me just bust out Chrome, right? Just by opening Chrome right here, it's going to Google, right? And that generates a session, right? It's going to Google on port 80, so I can open up a command prompt, and I'll do a netstat, just hit the enter key, and I can see right here I've got my my IP address, 172.30.100.223, that's going to, well, it's going all over the place. And right now it's just kind of hanging there because it's trying to do a reverse DNS lookup on some of the different things that I'm accessing. There we go. You can see, oh, I'm going to this device called RAX using the Telnet protocol. So now what I'm seeing here is 2 columns, right? Source stuff and destination stuff, right, that I'm going to. So with this is me and my source port number that Windows just makes up. This is my destination IP or host name. Here's an IP. And it's port number destination-wise that I'm going to. So if you type in, and this is why I say it's the most common mistake for folks to make, if you type in equal to right here, it's talking about the source port number. Very rarely are you going to do any kind of filtering on the source port. Because most of the time you're concerned with where are they going to. Now, yes, could you filter on source? Yes. Have I in the past? Yes. But it's rare. So usually I'll just leave that source port stuff right off of there and I'll move right along. So again, deny, permit or deny, there's part 1, protocol, source, and just move right on to the destination. It'll give you this option again at the end to type in a port number. Then you're talking about the destination port, right? Good. So where am I blocking to? I'm blocking them from going to the host. Host, again, single destination host. It's this guy, right? Block access to 192.168.2.50 on port, and now I can go in and say, now you can see I've got a whole bunch of options at the very end, one of them being equal to, but notice you can also say ports greater than, ports less than, ports in a range of ports. I mean, tons of options that I have in here, or packets not equal to a certain port number, all kinds of stuff. Right? So I'll do equal to, and this is where this big old list comes out. Never use the list. This is where I will say names are bad. Just use this. One of the things you will always do is remember common port numbers, like port 80 is HTTP, but for instance, in the names, they call it www. Right? Who's going to remember that? No, I'm just going to say port 80, and this is how easy it is. Hit the up arrow and squeeze in 443, but I'm going to go back to the beginning, move my cursor back there, Control A, and change that to sequence number 12. Check it out. Look at that. Squeezed 2 lines in right before that permit IP any, which now allows me to make that modification. So otherwise it would put it after the permit IP any, and it, based on the order of accessless processing, it just wouldn't work, right? So let's verify. How now you're saying, well, Jeremy, that's not a real PC. It's a Cisco router. How do you verify that accessless is taking effect? Telnet. You can actually do a telnet to 192.168.2.50, but telnet allows you to test different port numbers. So I can just go in and type in a specific port. By the way, if you have never used telnet in your troubleshooting, oh my goodness, is it valuable. You can telnet to, I don't even know if this will work. Let's try mail.cbtnuggets.com on port 25, which is SMTP. Oh, you got to spell it right, though. Have any of you ever done this? Of course, it's going to deny me. Well, let me show you this. I'm going to telnet to google.com on port 80, right? And notice the screen goes boom, blank, which means I'm connected. I can even type in get, and it doesn't echo the prompt back to me. But look at that. You're like, what'd you do? I just downloaded a web page to my command prompt, and it was like, okay, I'm done. Connection to host lost, because it essentially, this is all the HTML, JavaScript, whatever Google is using code that it just sent to my command prompt browser. And there are all kinds of stuff. But let me just, can I just say, go to Google and type in testing, squish this down, testing mom. How do you test your mom? Yeah, I'm going to tell you, I've gotten some of my best ideas for CB2 Nuggets by typing in these testing for herpes. Great idea. Anyway, testing a mail server using Telnet, right? And they will actually show you how to Telnet to port 25. This is perfect. And right there, it can show you how to send an email through a mail server. Look at that, telnet on port 25 using command prompt. Very cool, very useful for troubleshooting. And in our case, it allows us to test HTTP and HTTPS without having a web browser. Look at that. Bam, right there. 443, bam, right there. Let me just try 444. Look at that. Did you notice the difference? The delay? Essentially, one of them hit the access list and was like smack. Because notice right there, match, it hit that entry in the access list and immediately said, you are denied, close the TCP session. Whereas the one that took a little bit longer, notice just kind of, well, now it's not. Well, anyway, sometimes it does, but it took a little longer. It was because it actually got to the other side and started processing. A lot of times if the other side has an open port, like for instance, let me try 22, right? That totally blows my example. But my point is, a lot of times if the other side is not defended using an access list, it'll just kind of hang there. Actually, this was the perfect example. When I did the telnet to mail.cbtnuggets.com on port 25, it just kind of hangs there because it's getting to the other side and it's just kind of hanging there, timing out. Okay, now I can't open that session, right? So that is scenario 2. Pretty good, right? Well, let's look at scenario 3. Now, this one I specifically put on there to be done on router 3 because I want you to get back into the iOS XR. Again, the concept is almost the same. Well, actually, it is the same. The syntax is almost the same. It's just that almost. I want to make sure everybody's comfortable with it. We've got permit 192.168.2.0/25 to access 10.1.1.1 using only Telnet and SSH. Okay, so let's identify the players. This subnet, right, 2.0/25, so we got our funky wildcard mask that's going to make its way onto the scene, accessing this IP address using only Telnet and SSH. You know what I just realized? Using Cisco best practice, where are you going to apply that? Right there. Right, as close to the source as possible. But when I created that scenario, I wasn't thinking Cisco. Oh, sorry, I hit my mic. Wasn't thinking Cisco best practice because I was thinking, oh, I got to block this. So I wanted. So I'm gonna forego Cisco best practice because I want you to see the syntax on iOS XR. Right. So we're gonna have these guys cross. Oh, I know it's a long WAN link just to be denied right here, but you get the point, right? That's my goal is to show you iOS XR. Let's bring up router 3. Shoot over there. Sitting at the prompt XR1 Cisco. We are in. Okay, so we're sitting on router 3. Let's do a show IP interface brief. Just to get the lay of the land, we've got, just like the scenario is showing, the interfaces connected to their respective networks. Okay, so on iOS XR, now the beauty of this is, this does not take effect right away. Remember, all the iOS XR is kind of just sitting in this limbo until you commit it. So it allows us a lot more flexibility with blowing up our connection based on a misconfigured access list. I'm grateful to Cisco for that. But I will say, today is, what is today? April 14th, 2014. And we're about a week after one of the world's biggest security flaws ever. You probably, maybe it's old news by the time you hear this, but right now it's kind of hopping, and that is the Heartbleed SSL vulnerability. Essentially, OpenSSL, which is used in Linux systems everywhere, was found to be vulnerable with this Heartbleed vulnerability, which allows people to essentially get in. I shouldn't say get in, but access areas of the device's memory unencrypted, which could include private keys and stuff like that. Not good at all. And the iOS XR is built on a Linux foundation, so it was vulnerable. So it just all the iOS devices were like, aha, because they didn't have this OpenSSL, because essentially Cisco created their own little SSL for the iOS, whereas iOS XR needed some immediate patching on devices around the world. So here we are on the Linux-based iOS XR. IPv4 is the command access list, and we're going to say, okay, so we're permitting only Telnet and SSH. So I'm going to say, we'll just call it block 2, right? Block 2. Now we've got our sequence number and all that. Now we can go into our little access list configuration mode, but I kind of like staying at the surface if I can, and just do it all right here. We'll do block 2 permit, and then based on what we type here, the iOS XR knows whether we're creating a standard or extended ACL. If we go right into the source IP information, it goes, oh, you're using a standard, because that's what standard do. If I type in a protocol, it goes, oh, okay, you're using extended. So in this case, I'm going to say TCP, right? Notice again, instead of IP, it's IPv4, just like most things in the iOS XR. So TCP is going to be what's permitted, and we're going to do 192. I've just backed myself into a corner here. It says permit 192.168.2.0/25 to access 10.1.1.1 using only Telnet and SSH. Well, if I was following Cisco best practices and applying it here, then that's easy. But since I'm applying it here, it makes me think, well, what about everybody else? What about this subnet and this subnet and everybody else that could be accessing this 10.1.1.1? Since I'm applying it right here, I have to think about them as well. And we'll say, and no one else. How's that? There's my quick scenario modification. You can actually do that on the certification exam too. Okay, so permit 192.168.2.0 is going to be the source wildcard bit 0.0.0.127. Lest you misunderstand my sarcasm, you can't do that on a certification exam. What is the source port? I'm not doing the source port. I'm just thinking about destination. So I'm going to say when they are coming into let's do the host 10.1.1.1, right? Because I'm talking destination host. on, now it's going to ask, same kind of thing as the iOS, what port number. So I'll say equal to 23, enter, and equal to 22, enter. It's going to do the sequence numbers for me behind the scenes. So let's do a quick show access list. Oh, I haven't committed it yet. Right. Well, it's there, believe me. And so I'm going to do, so we've got the blocks, right? But if I just leave it at this, then the only thing that will be permitted to that IP address is this subnet, right? Because we've got the implicit deny. And as I'm sitting here thinking, it's just putting this on this router changed my whole scenario. Does that make much difference? Let's think this through with me, right? So we're now saying we've got this subnet accessing this IP address using Telnet and SSH. So I created an access list entry saying 22 and 23 are allowed right here using from this subnet, right? 22, 23. Okay, so deny everything else. Does that hurt us? Yes, it does. Okay, why? Because OSPF is running between these guys, right? And OSPF will be denied from this guy. I'll be like, OSPF will fail, and then we'll lose complete connectivity. Okay, so we want to kind of get a little more specific. Okay, so this is good. I mean, it's a good mind thought process. So we're going to do IPv4 access list block 2, and what I'm going to do is say deny. Let's do deny IPv4, right? From 192.168.2.0. To WildCardMass 127, right? To the host 10.1.1.1. Okay, hang on. Let's commit that. I mean, it's not applied yet, so we'll just kind of go back and do a show access list. And we've got IPv4 access list. So right there, we're saying permit this subnet to use Telnet. Permit this subnet to use SSH or port 22. They have friendly names for some, not for others. And then it says deny this subnet from anything else. And that commits this scenario to that host, right? But now we need to say line 40. Let's do access list. Well, I'll just type the whole thing out. IPv4 access list block 2. And we will do permit IPv4 any. Commit. You good with this? What do you think? So this says just Telnet and SSH. Deny everything else, right? From that subnet to that host, and then permit IPv4 any. Now, can I take just a moment to mention, and actually answer this for me? Take this as your trivia question. This is going to be a good question. It gets a lot of people. If these guys telnet to this IP address, will they be denied? Yes. Well, I'll say once that thing is applied correctly, yes. Once we apply it inbound, let me do that, inbound on that interface, yes, they will be denied. Okay, well, what if this host telnets to that IP address? Can they get in the back door and access that router and manage it? Think about that. Can they do that? Yes, they can. Huh? Whoa, wait, huh? Wait. I know some of you are like, yeah, I totally get that. Other people are like, well, hang on, wait, because you denied them from everything else except this IP address, right? Well, yes, but remember when we're talking about an extended access list, we get to specify the specific source and the specific destination. So when the packet comes in, so if let's just open our virtual Wireshark. You may not have known it. This whiteboard is all Wireshark capable and all that. So when they telnet, what is the here's your data telnet, right? That's your data. In the header, you've got TCP is chosen, and then we've got the source IP address. What's the source IP address? 192.168.2.50, right? That's this guy right here. What's the destination IP address? What is it? 192.168.2.129, which is this IP address right here. So think of this as just a programming system, right? A processor, if you will, of programs. This packet comes in and gets lined up. Hang on, I'm changing my pen modes. Whoo, we're going big now. I'm taking this packet against this access list, and it's coming in. It's going, okay, are you trying to access this IP address via Telnet? No, so this is no match. This IP address via SSH? No, this is no match. So that comes right here. It goes, okay, are you being the entire 192.168.2.0 subnet, are you trying to access this IP address via Telnet, but actually, hold the phone, via everything, because it doesn't matter what you're accessing it with, you'll be denied, and the packet calmly answers without sweating a drop, no, I am not. I am trying to access 192.168.2.129. So the router goes, oh, okay, well, you're good. Then this whole line doesn't apply to you because this just applies to people accessing that IP address, right? Oh, good. That's so good. And then comes down here and goes, okay, well, then you're totally good. So if your goal was to secure your router from Telnet and SSH access from this subnet, you just failed. Well, at least if this IP address allows Telnet and SSH access, right? Because people can find this backdoor in because of it, right? Okay. Well, whether we pass or fail, our mission doesn't matter. Whether we accomplish this goal is what matters. So I'm going to go in here and I'm going to go to interface G0/1/0/0, which is that kind of WAN link, if you will, coming in. I'm going to do an IPv4 access group block 2 inbound and commit that bad boy to running configuration. So now I can do a show access list. It is enacted. Come on over to, oh, it's PC2, right? That's this guy. And telnet to 10.1.1.1. Bam. Telnet to 10.1.1.22. Bam. Telnet to 192.168.2.129. Well, bam, now it's denied just because I haven't enabled Telnet. I'm accessing all these things on the console port. So Telnet or VTY access into that device is denied. But at least you saw it hang there for a moment, right? Or maybe we could do a 22. Yeah, now we're getting the smackdown. But you got the idea, right? That's how we can go in on the iOS XR and do those extended access lists. The trifecta is complete. Fantastic. We have seen over the last 3 nuggets some pretty amazing stuff. I get excited when I talk about access lists because it really is like putting puzzle pieces together. It's fun. We have seen access lists knowing, even though our scenario just showed using them for access control, we know that they can be used for so much more. NAT, VPN, quality of service, access restrictions, stuff that I can't think of right now. There's all kinds of stuff that these things can be used for. They're just lists of permit or deny statements. How we apply them is how they take effect. So that was the original. We then looked at standard access list syntax, walking through 3 scenarios there. Then we went, it's more powerful if not only color the bullet, but put the checkbox next to it. Then we went into the extended access list and did not 1, but 3 scenarios using extended access list to control access. I will tell you, this is a big part of your SPNGN2 exam, knowing access lists. That's why I spent so much time on them, how to configure them, how to recognize what they're allowing, what they're denying. I mean, get ready. Get ready for not only maybe some scenarios where you have to configure them, but also recognizing in a configuration what would be allowed, what would be denied. I mean, these are just the normal Cisco kind of questions that are thrown at you. Good. I hope this has been informative for you, and I'd like to thank you for viewing.